to C++ Fundamentals, Part 2. My name is Kate Gregory, and I'm continuing my introduction to C++, the most popular general-purpose programming language in the world. In this module, I need to show you some C++ code that's really not much fun. It's old school. I've said repeatedly, modern C++ is readable, it's safe, it's understandable, it's maintainable. The standard library does so much for you. It's not like that old C++ you heard stories about. Well, in this module, I'm going to show you that old C++ you heard stories about. Not just as a badge of honor that I happen to know it, but because as a C++ developer, people are going to give you some of this code. It might be a sample, or it might be the old code that they're asking you to maintain. So you need to learn how to read it. I hope you never have to write it. Let me show you what I'm talking about. With typedef, it's a keyword, so it starts with a lowercase t. And as you might guess from the name, it's used to define your own types. Here's a couple of examples. When I say dword, I really mean an unsigned long. When I say bool in all caps, I really mean an int. It was really popular, especially in C, when if you wanted to define a struct, you had to then, every time you declared instances of that struct, actually use the word struct. So you didn't say point p, you said struct point p. People would use a typedef to save themselves from having to type those extra few characters. But it was also done to add meaning to types. When you say something is an unsigned long, it might just contain a number between 0 and the largest possible number that can fit in a long. When you say something's a dword, sure, it's being carried around in a long, but you're giving some information about what the value means. In this case, that it means a double word or two words packed into that long. People see that bool in all caps, they get super confused because the lowercase bool is a built-in type in C++. Why would anybody use this different bool? By and large, it's a holdover from the time before the lowercase bool was a type in C++. The early 90s or so seems like when it was added, so almost 20 years ago. And those of us who were writing C++ before then had this idea of true or false and no type to put it in. And so by saying typedef int bool, it's actually carried around in an int, but if you go calling it a bool, then you just, by practice or convention, only put 0 or 1 in it, and it carries a little extra information. When I tell you a function returns a bool, you think of it differently than if I tell you it returns an int. Now, you might ask why, after 20 years, you can still find applications that have the all caps bool in them. Sometimes people don't want to fix code that's not really broken. And other times people went in to fix it and found out, because the compiler just treated them as ints, some of those functions return values other than 0 and 1, and I don't want to get in there trying to fix it up. We'll just leave it alone and have it return this all caps bool. So you will still meet it, especially if you're writing Windows programs. Now, one place I still use typedefs to this day is in function pointers, which we'll talk about shortly. When you see something in the place where a fundamental type or a class name belongs, but it isn't colored blue like int would be, it's just regular black text like the rest of the code, that actually tells you that it's a typedef, and you can hover over it and Visual Studio will remind you what it is. Let me show you that really quickly. I have a demo here that we're going to use throughout this module, and you can see that my int and my long are blue and this dword is not. And if I hover over it, typedef unsigned long dword, which you can also see up here. It's still an unsigned long, but the compiler is aware of typedef. This isn't just some sort of a text substitution. So if I make this mistake here of trying to put a literal string rather than a number into my dword, D1, I get red wigglies, which if I hover says a variable of type const char star cannot be assigned to an entity of type dword. So the compiler knows this new type that we've invented and gives us error messages that make sense for that type. I have a header file here called point, in which I do this struct thing. This was really common in the old days. Typedef struct, and then you had to give it a different name, and there was a very common pattern to put the word tag in there. So typedef struct tag kpoint, and my struct has an integer x and an integer y, and then this is what the typedef has been defined to be. So all this part is what a kpoint is. And that sort of maps with here, where all this is what a D word is. When you've done that, then you can write this kind of code. I have a kpoint called P and then talk to its X and its Y. And all of that's legitimate. This builds fine. You can see down here it says build succeeded, but it's just kind of pointless today. If I take this code and comment it out, then take this and uncomment it, you'll see this is a very more readable, simple version of the exact same thing, struct kpoint that has an X and a Y. If I leave the code that's using kpoint completely unchanged and just build again, this build also succeeds. So in terms of ease of using the struct, this code couldn't care less how you do it. And I find this neater and more readable than this kind of old-fashioned way. If you come across the old-fashioned way in someone else's code, now you know what the heck it's doing. If you want to, you can change it to this, or you can go with the if it ain't broke, don't fix it rule, leave it alone. Now you know how to read it.